Hey guys, so this is the final project for my informatics 685. The instructor's name is Dr. Bhaskaran, and this is for the fall 2019 healthcare software requirement specification and system analysis and design. So this is actually more of the presentation for the um, requirements, traceability matrix, and also the system design document. And the scenario is more for the comprehensive community-based approach for reducing inappropriate imaging, which I talked on the first slide. So the second slide talks more on the introduction and the scope. So here in this slide, what I talked about is more on the introduction, which is how the radiologists are kind of subjected to various image studying in order to diagnose patients. However, to be able to optimize the image study and achieve the highest functional result, thereby reducing the cost and also the redundancy. Redundancy is also the purpose of this developed system. The system also aims to improve the report to image navigation process by providing hyperlinks to images. Over here, we have to develop and evaluate a regular expression-based algorithm that recognizes image references at a sentence level. Radiology workflow can actually work this way when a patient performs an imaging study. It's going to be like modality, such as the CT, the X-ray, the RI. The images are also being transferred to the picture or chart and communication system packs using digital imaging and communications in medicine standard. Radiologists kind of reads images stored in packs. So if the order has been created by the radiologist or the say like the physician or the provider puts in an order, it's like a CT scan, lab, X-ray. They go through the packs, they generate a radiology reports using the software, which is like the reporting software. The report is then kind of transferred to the PACS or the radiology information system, depending on the hospital IT infrastructure, through the L7 level, which is also a language which different kind of EHR or machine language interact with. To achieve the highest optimization and efficiency of this patient's image by the radiologist, it is developed in a way where it allows image referencing around the radiologist's reading platform by kind of hyperlinking, referencing, and artificial intelligence. The third slide talks more on the project executive summary. So I talked a little bit about how the system is developed and the conviction that several image studies results to much more than enough redundancy, of which it has been created to optimize the image use by establishing a viable platform for data exchange between primary care and image facilities. This is also intended to reduce image cost without any loss of diagnosis accuracy. The design constraints I all talked about here seems to work with the system, having to solve the kind of radiology-related issues by having to digitalize different image data, which are previously done in a traditional way. Anyway, this has actually created a drawback of not being able to retrieve and display the patient's medical images automatically, thereby making the user to collect the images manually. Sometimes some images exchange lack of interoperability with other facilities, and this sometimes kind of causes a stumbling block between the natural workflow of communication between these facilities. So I had a diagram here which talks about the system overview of the PACS communication. I have the CT scan, I have the MRI scan, I have the CM, I have the ultrasound, which goes into the LAN, which is the local area network. It goes into the PACS machine, and then it goes out here. This is the PACS client, and now the workstation over here. The fourth slide talks about the purpose of the requirements management. Here, I talked about how the plan collects necessary information about imaging studies, like CTs, MRI, labs, and the likes of them in the shoulder, the chest, the abdomen, the head, the lumbar spine, the lower extremities, and cervical spine at Alterum Institute. I feel like the main objective of this project is to reduce the CT volume by 17.4% and MRI by 13.4% for 3 years. And this actually tends to reduce 17% overall cost of imaging. So necessary data is needed about training of the technology and system to care providers for implementing the proposed project. Of course, we know we definitely have to actually train these physicians to be able to actually use the PACS, put in orders, radiology orders, CT orders, and sign it so as the order can actually cross over to the radiologist. The plan is created in the planning phase to document required data for managing project from description, traceability, and ending with final delivery. This plan is mainly designed for the project team, manager, and the sponsors. In the fifth slide, what I talked about was the assumptions, which is requirements management. I talked about the assumptions and the constraints, which is to impart knowledge about imaging to the patient. A comprehensive education program is developed. This program must consist of information about, information about care guidance and risk for radiation, as well as procedural costs. The comparative assessment report will also be provided to the physicians about the system utilization. The requirements definition here talks about major project requirements, which includes like the virtual care tool used for virtual care of the patient with a cost-effective mobile application. This kind of tool is actually used to help in rapid development of audio cameras, cloud system, as well as remote monitoring. We also have the cognitive technologies, which is used for human intelligence. Artificial intelligence is kind of used to manage a very big chunk of data, deep learning, as well as robotic application. This technology is kind of utilized for automatic reporting and making decision support systems. The other I want to talk about was automation. This technology is required here to automatic scanning, reporting, making decisions, as well as preparing instructional materials for patients. Requirement traceability. Here we have various approaches and tools used for tracing the project requirements. And they're as follows. Interviewing techniques, various interviews are done, surveys. You have literature review, where you have various research papers, journals, articles, and magazines that can be studied to gather knowledge about the proposed project. Data collection about current tools and technologies from various organizations that are using effectively. The workflows and activities. The actual flow of the proposed system and required procedures are known as the workflow. Here, we'll talk about during and after implementation of the proposed system. Workflow can either be changed, be modified per the hospital's requirement. The physician's workflow with the clinical decision support designing, timing as well might be structured. And I also talked about how we can generate auto-reporting and materials for patients and forwarding to ImageSmart's patient-facing website. Change management for implementation of the clinical decision support and to align workflow. I feel like the workflow and clinical decision support can be redesigned due to changing of physician's design and structure to improve the processes and the changes of the workflow which can be done. And after analyzing the workflow, as well as identifying the improvement of the process and the process of helping clinical decision support system, which is well known. The next one is the PACS communication network. In the PACS communication network, here it's actually the way of moving the medical data between the components of PACS themselves and other systems, and to also remote locations. PACS network provides a path to communicate between imaging modalities, gateway computers, PACS server, display and review workstations. The factors of the PACS network are the network topology, the line capacity, and the workflow assignments. Pretty much we talked about the 5 main topologies used in the medical environment, which are the ring, the star, the tree, the boss, and the mesh. Theoretically, the 3 main types of network that are used to transfer the medical data of radiology: LAN network within one medical department to link imaging modalities, archive, and data storage on the display workstations; LAN network to link different departments in the hospital, intra-hospital; and the teleradiology network, which is used to transfer medical data to other remote hospitals in that region. So I talked about the PAC server down here, the archive manager here, talked about the modality gateway right here, and the hub. So this is how the HIS interface, clinical workstation, and web server are all connected down here to the hub. The diagnosis workstation connected right here to the network connected to the modality gateways and down here. And so this is how the workflow looks like. The 7th slide, I guess, talks about the PAC server in a way that all the patient information and imaging examination are directly sent to the PAC server for archiving. The data is sent to PAC server from the acquisition gateway computers. The PAC server, which is the heart and engine of PAC's, has 2 main components: the storage media, which is the database, and the archive system. The archive system of PACS needs 2 levels for archiving: the short term and the long term. The display workstation is a very important component of the PACS network, kind of plays a vital role in the clinical acceptance of PACS. It's the hardware component that replaces the alternator of the manual light box of a radiology system. So this is a diagram of the display workstation and a diagram of the PACS server right here. On the 8th slide, I talked about the appendix, which is the key terms. Talked about the different terms and definition: CMI, Center for Medicare and Medicaid Innovation, ImageSmart, and the NSA. And I also talked about requirements traceability templates, where you have different kind of ID of requirements, use test case, the version, and the errors found. And I gave some examples right here. The 9th slide talk about system software architecture, and here we'll see right here the doctor places the radiology order. Doctor clicks on the link to see the x-ray. X-ray technician takes x-ray and collects data. X-ray tech inserts collected data, submits the data for study. Doctor views x-ray in diagram format and links on a patient's page. So we'll see the interconnection between these images. Doctor places radiology down to web portal. So all these, we see the connections. And also over here too, we see like how the web portal, the DICOM web portal, and all these are also connected to as well. So the workflow features and references, and we have an overview of how all this works right here, which kind of makes sense. The 10th one, we have different references. So this is where I got all of my references from: requirements management plan, CDC, and all of these right here. Well, thank you guys.